We read a number of CERs about the whale of tail, and we have some feedback for you. First of all, it seems like many of you might not have used the resources that we gave you to write that CER. When you write a claim, the claim should be your words, not just the words of the prompt. And what might help you prepare for writing a better claim is by going through these slides. We gave you a lot of information about how we studied whale diversity, and we followed the fossil record and where the whales came back and how it was a journey through time using the fossil record. We looked at the teeth, we looked at the size of the skull, we looked at where the fossils were, how the land masses changed. DNA was one of the evidences. Embryology is also more evidence. When we look at embryology, we want to notice that all the embryos look very, very similar between the reptiles, the amphibians, the birds, and the mammals at the beginning, but because of how they lived and where they evolved, they developed different things based on genes being turned on and off to end up as the species that they are to be successful where they live. The DNA data. I noticed a lot of you did not finish your DNA data. That probably made it a little bit difficult for you to do the next unit, where I want you to be very comfortable with looking at codons and comparing the nucleotides to one another. You should, some of you said that the right whale was very related to the sperm whale or the sperm whale to the porpoise, but all three of these were cetaceans. You were supposed to compare them to the hoofed animals, which were the perissodactyls or the artiodactyls. That depended on how many toes they had or hooves they had. And then we gave you all the answers. So the DNA data sheet was more a practice in using the DNA. But when you answered these questions here should have been one, complete sentences. Many of you are using 2 or 3 word sentences. I'd like to see you approaching high school level with these. But you should have talked about how the number of DNA differences tells you how closely related the mammals are. The more differences, the farther apart they might be on the evolutionary tree. The artiodactyl was definitely more similar to the cetaceans. The hippo should have been your answer there. And what inferences you should have made about four-legged animals being closely related to those mammals. You could have used embryology there. You could have used the DNA and how the segments were maintained throughout the species. Ultimately, please use spell check. I would like you to open up your CER and re-listen to this video and look at your claim. Was your evidence specific? Don't just tell me the evidence, but tell me how the evidence supports your claim. And then the reasoning is beyond the evidence. What does that mean? Where does it take you? How can we use it in a more general sense? Talk about maybe the hunt, the fossil record, the skull, the teeth, the hooves, the embryology or comparative anatomy of whale fins to human arms or dog legs, and then closing it with a really strong evidence of DNA segments being similar, meaning that they're more closely related than those animals that don't have DNA. Please work to be high school ready by writing very high level CERs as well as answers to any of your questions moving forward. Have a great day.